Hey everyone, in this video I'm going to be talking about non-Mendelian genetics, and in this specific video I'll be talking about codominance. We're also going to be talking about clues to recognize them for chi-squares. So remember that for non-Mendelian genetics, you are going to find that sometimes you have to reject the null hypothesis because the organisms did not follow the predictions that you made using a Punnett square or dihybrid cross. So the ratios are going to be off from the numbers that you predicted, or a new phenotype is going to show up that you didn't expect. And so in this video, we're going to be talking about the 8 reasons why a null hypothesis would be rejected, and those clues to tell you which type of non-Mendelian genetics are responsible for spiking up your chi-square at such a high value. The first one I'm going to talk about is codominance. In codominance, what happens is a heterozygote has an expression of both alleles for the same characteristic. So, for example, these cows, you can see both white and brown being expressed, and in these flowers, you see red or pinkish red and white both being expressed. So one does not completely remove the other one. You're able to see both, and it's not a blend of the two. You're able to see both. So if you were doing a Punnett square and you wanted to figure out, if you wanted to know if you could use codominance as the reason why the organisms did not come out the way you were expecting, what you would see is, number one, a completely new phenotype that you weren't expecting. And the thing about this new phenotype, again, is that it's expressing both alleles. It's expressing 2 of the phenotypes that you weren't expecting. And this will typically be with heterozygotes. So the most common example that we are going to talk about is blood typing. So with blood typing, there are 3 different alleles that we can be looking at, and 2 of them are codominant. One of them is completely recessive. So for my dominant, we use the letter I, and that letter I, if we want to indicate as A-type blood, we add an A, superscript A. And if the other dominant form is the B-type blood, we would add a superscript B. So this individual has AB blood. They have both A and B markers on their red blood cells. And both of these are completely dominant to O-type blood. O-type blood is recessive. I hope this video was helpful. Thanks for watching. Bye.